Hello, and welcome back to Math Extra. Big shout out to Miss Green and Mr. Leichner for some great lessons we just saw. My name is Mr. O'Neill, and I'm a teacher at Piedmont, IB Middle School. And to all my 8th graders, here we go. Let's get ready to do the math on Math Extra. All right, you know what time it is. It's time to reveal the Math Extra credit from last week. So let's look at the math. I'm going to work it out now. So last week we were given the problem -2 squared times -1 to the 0 power times 3 to the 0 power times -5 to the 0 power. So remember, I taught you last week that when this negative is in front of a number and it is not in parentheses, we're saying the opposite. So 2 squared is 4. The opposite of that is -4 times -1 to the 0 power. Now, again, we are saying the opposite of 1 to the 0 power. So 1 to the 0 power is 1. The opposite of that is -1. So we get -1 here times 3 to the 0 power, again, is going to give us 1 times -5 to the 0 power. So we're saying the opposite of 5 to the 0 power. 5 to the 0 power is 1. The opposite of that is -1. So here is the problem that we have. And now we're going to multiply straight across and see what the answer is. Let's go. So we have -4 times -1 is 4, because a negative times a negative is a positive. Now we take that 4 and multiply it by 1. That's still going to give us 4. And now we take that 4 and multiply it by -1, and that's going to give us -4. Did you get it right? Don't play. Did you get it right? Okay. Make sure that you pay attention to those negatives, because the negative says take the opposite of the base. Remember, the base is not negative. The base here would be positive. All right, so now let's look at our lesson for this week. Here we go. It says, what is any base raised to a negative power? So last week we looked at any base raised to the power of 0. This week we are looking at the base raised to a negative power. So let's look at our lesson. So we have all these numbers, and they are raised to a negative power. And finally, we're wondering, what is any number raised to a negative power? So let's look at last week, because last week is going to build on our lesson for this week. So we got to go back to last week to bring us up to this week. So let's go. So we learned last week that while we're moving down a power, we are dividing by the base. So that was the pattern, that as we move down the power, we are dividing by the base. Here the base is 2, so we're dividing each number by 2. And so when we get here, 2 divided by 2 is 1. And the same rule applied over here, that as we move down a power, we are dividing by the base. And so 3 divided by 3 is 1. Same thing over here, that as we move down a power, we are dividing by the base, and 4 divided by 4 is going to give us 1. So remember last week, we saw that anything raised to the 0 power is 1. It's not 0, it is 1, because as we move down a power, we are dividing by the base. All right, so this is what we said. We said that any number raised to the 0 power is 1. Then we said that any number raised to the 0 power, and if I have a negative sign outside that number, that is going to give me -1, because this negative sign says take the opposite of x, or any number, to the 0 power. All right, you got that? Okay, make sure you have that for the lesson today. So let's keep moving down the power. Let's get into this lesson. So we know that as we move down the power, we are dividing by the base. The base of 2 is here. Yesterday we stopped here. And so we're going to keep moving down the power. So when we move down the power, what are we going to do? We're going to divide by 2. And then 1 divided by 2 is going to give us 1/2. 1/2 divided by 2 is going to give us 1/4. And 1/4 divided by 2 is going to give us 1/8. Okay? So that is what we have so far. Now, some math scholars believe there's no such thing as division because a division problem can be the same thing as a multiplication problem. So dividing by 2 is the same thing as doing what? Multiplying by 1/2. So some scholars says, hey, there's no such thing as division. I'm gonna let you all decide that. Let's look at the second column. So here, we have 3 to the 3rd power. So I can move down the power by dividing by 3, or what I just said, as we move down the power, we can multiply, let me get the multiplication symbol, multiply by 1/3. Okay, so as we move from 1 to the next power down, again, we're looking at the negative exponents. We are dividing by 3 or multiplying by 1/3. 1/3 times 1/3 gives us 1/9. 1/9 times 1/3 gives us 1/27. So again, as we move down the power, when the numbers become negative, our rule doesn't change. We're still either dividing by 3 or we're multiplying by 1/3. Now let's look at the last column. So yes, on the last episode, we said, again, we are moving down the power. And if we move down the power, we're dividing by 4 or multiplying by 1/4. So 1 divided by 4 is 1/4. 1/4 divided by 4 is 1/16. And then 1/16 divided by 4 is going to give you 1/64. So again, as we move down the power, we are dividing by the base. Now let's pay attention to the negative powers because that's our lesson today. Let's pay attention to the negative powers. Let's look. So over here, -1, -2, and -3. So 2 to the negative second power, 2 to the negative first power yielded us 1/2. 2 to the negative second power yielded us 1/4, and 2 to the negative third power was 1/8. Are you noticing something? Because I'm noticing something. I am noticing another pattern. So let's look deeper. So I noticed that 2 to the 3rd power is 8, but 2 to the negative 3rd power is 1/8. I'm noticing that 2 squared is 4, but 2 to the negative second power is 1/4. 2 to the first power is 2, but 2 to the negative first power is 1/2. I'm seeing that when the power is positive, the number 8 is now in the denominator. So let's see if that's true in the second column. So 3 to the negative 3rd power is 1/27. Well, will you look at here? 27 is right there. 3 to the negative 2nd power is 1/9. And now the 9 is there. Again, the 3 is there. And now the 3 is in the denominator. The same thing is happening in column 2. Let's look at the last column because I know you already figured this out. Let's look. So what used to be 64 is now 1/64. What used to be 16 is now 1/16. What used to be 4 is now 1/4. So our rule is producing a new rule. Looking at the negative powers, it seems if it was positive, it used to be in the numerator. We can say that the 16 is in the numerator, okay? And then as we move to the negative power, it is now flipping in the denominator, okay? So let's look again. So when we look at 4 to the 3rd power, it's here, 64. Now 64 can be written as 64/1. That's understood. That's 64/1. And then now we get 4 to the negative 3rd power. It's 1/64. Now I want to caution you real quick because I know that some of y'all are thinking, well, they're just flipping places. But I'm going to show you that they're not. But I'm going to show you later. Stay tuned. I'm going to show you later. All right, let's look at the next things because I want to bring this home. So I want to just look at the numbers as just a base and an exponent. 2 to the third power is 8, and we know that this matches to this problem here. So I have 2 to the negative third power. 1 over 8 is still 1 over 2 to the third power. Again, this 4, 2 squared, matches here. We said it was 1/4, but 2 to the negative second power is going to give us 1 over 2 squared. 2 to the negative first power is matching with this one, and it's going to give us 1 over 2 to the first power. So, are you seeing what I'm seeing? Hopefully you are seeing what I am seeing, and I'm not going to reveal it yet because I want to see it one more time. So let's look at the second column. So again, 3 to the third, 3 to the negative third. This can be written as 1 over 27, which is the same thing as 1 over 3 to the third. This is the same thing as 1 over 3 squared. This is the same thing as 1 over 3 to the first power. Let's go to the fourth column because you already know I'm going to go there. 4 to the third power, if it's now negative, becomes 1 over 4 to the third power. 1 over 4 squared, 1 over 4 to the first power. So, I am seeing that if I have a base to a negative power, that base is now flipping and that exponent is becoming positive. I'm going to say that again. When I have a base to a negative power, the base is now flipping and then the power or the exponent is becoming positive. Let's make sure you're seeing what I'm seeing. So 2 to the negative third power is now 1 over 2 to the third power. 3 to the negative second power is now 1 over 3 to the second power. 4 to the negative first power is now 1 over 4 to the first power. So, this is what I'm seeing. If it's a base and a negative power, the base is flipping and the power is becoming positive. Let's look one more time. So I am going to look at this and I'm just going to concentrate on just negatives. So we saw last week that these were the zeros. We know that we are dividing by the base, moving down. So I am seeing that, look at the pattern going down. Yep, if we look at the pattern going down, we're dividing by the base. What happens when you raise a base to a negative power? What happens is if for any number x raised to a negative n power, I am noticing that we are getting 1 over x to the n power. Are you noticing the same thing? I know you are, because it's all over the place. So if we raise any base x to the negative n power, we end up with x, 1 over x to the n power. Again, x represents any number and n represents any number, but we're saying negative number. So I know that you're thinking this. Watch this on the next example. So what about this? So this scenario, 1 over 2 to the negative third power. Mr. O'Neill, what am I supposed to do here? What am I supposed to do here? Well, I'm telling you the rule. The rule is this. Watch my language. That for any base raised to a negative power, we flip the base and the exponent becomes positive. So watch this, okay? So 1 over 2 to the negative third power can be written, y'all know I love rewriting things so we can see the math, can be rewritten as 1 over 1/8. We just saw that. So if this is 1 over 1/8, what is this saying? This is saying 1 divided by 1/8, which is saying this. How many eighths can we fit into one whole? How many eighths can we fit into one whole? Well, here. I know that if it's eighths, I can fit 8 eighths into one whole. And what is 8 as a base and an exponent? Come on, I know you know this. I know you know this. I know you know this. 8 as a base and an exponent. We've seen it all day right now. Okay? It is 2 to the third power. So what did I do? I did the rule, everybody. I did the rule. The rule was flip the base and make the exponent positive. Watch. 2 to the negative third power is here. Where will it flip? It'll flip here. Look, we flipped the base and the exponent became positive. So it doesn't matter where the base and the negative exponent is at. If the rule is to flip the base and make the exponent positive, then we're going to follow the rule no matter what, okay? So that's it for this part of the lesson on understanding what any base raised to a negative power really is. This whole Math Extra thing really doesn't work if we're not reaching out to students. So we asked our viewers to give us a call, ask a question. Let's do this math thing together. And right now, I believe we have a caller on the line. Hello, welcome to Math Extra. Caller, are you there?
Yes, I'm here. Hi, Mr. O'Neill.
Hey, what's your name?
I'm Melissa.
Oh, Melissa. What grade are you in, Melissa?
I'm in 8th grade.
Okay, cool. Nice to meet you, Melissa. What's your question today?
So I'm a little confused on this. So what is 2 over 2 to the negative third power? Wouldn't that be 2 to the third power over 2?
Wow, Melissa, that's a good question. And I alluded to that earlier, so it's amazing that you're asking this. Okay, so let's look at the math. So you're saying what is 2 over 2 to the negative third power? Isn't that 2 to the third power over 2? Is that correct?
Yes.
Okay, so Melissa, this is what I want to say, is we only move negative exponents. It's if you already have a positive exponent, you're good. We don't need to move you. We don't need to flip you. We're only moving negative exponents. So when we look at this problem, I'm going to break it down for you and hopefully you'll understand.
Okay.
So 2 to the negative third power, we just saw this, can be written as 2 over 1/8. And we just said that if 1/8 is over 1, 8/8 fit into 1/8. So, Melissa, if I can fit 8/8 into one whole, that means 8 of those can fit into 1. How many 8s can I fit into 2?
16.
16. Good job, good job. So let's look back at the problem. So I can fit 16 8s into 2. So that becomes 16. So now let's really look more deeper at the math. So if our answer is 16, because I can fit 16 8s into 2, let's look at what you said. 2 to the third power. Okay, Melissa, 2 to the third power is 2 times 2 times 2. What is that?
That is 8.
That is 8. And then 8 divided by 2 is going to give us what, Melissa?
4.
4. That is not the same answer as 16 as it really supposed to be. So the issue here, Melissa, is that students, when you start teaching about negative exponents, they just want to start flipping everything. Okay, I see a -3. I'm going to flip that to the top, and I'm going to flip the 2 to the bottom. But we only move negative exponents. If it's already positive, you're good. We don't need to move positive exponents. So let's look at this problem again. So let's look again, Melissa.
Okay.
So we have 2 over 2 to the negative third power. And if I use my rule that I just said, is that I'm going to flip this to the top. Now, Melissa, The issue is this is the issue, is when we're used to seeing it just like 2 to the negative third power and you know it's over 1, students believe that you're flipping the entire fraction. So watch this. I'm going to go back to the previous lesson. So if I have 2 to the negative third power, that's going to give me 1 over 2 to the third power. We just discovered that rule. And last week we understood that I can rewrite this as 1 times 2 to the negative third power. So Melissa, the 1 is not moving. See, the 1 is it really doesn't get a lot of love in math because it's not necessarily needed all the time. So when we look at this problem, some students feel like, where did the 1 come from? The 1 was already there. We didn't flip the 1. So look at this, Melissa. The 1 was there. We flip 2 to the negative third power, flip the base, and the exponent becomes positive. So on this problem right here that we started back, what you're asking, we are not flipping the 2. Melissa, we are not flipping the 2. We are flipping 2 to the negative third power. And when I do that, this is what happens. The 2 stays there because it's positive. And then the 2 to the third power is joining through multiplication, which reminds us, remember that the 1 was already there, the 2 has to be there. So here's the deal, Melissa. 2 to the third power is what again?
8.
8. And now we're saying 8 times 2, which is going to give us what, Melissa?
16.
16. Now, Melissa, I'm going to throw this little bonus at you. Now, 16 can be rewritten as a power and a base. 16 is actually 2 to the 4th power. Now, Melissa, I know you didn't ask for this, and you might not be ready for this, but I just discovered another exponent rule, because if I look at this again, let's look at this problem. If I read 2 to the 1st power times 2 to the 3rd power, what is 1 plus 3, Melissa?
Wait.
1 plus 3.
Oh, 4.
4. So I just saw that if you multiply the same base and with an exponent, it looks like we're adding, but that's not the lesson today. But again, that is why math makes sense. Does the problem make sense now, Melissa?
Yes, it does make sense.
I'm so glad you called in today. Eighth graders, you know what time it is. It's that time for the Math Extra credit. Show what you know and answer this challenge. All right, here's the question. 2 divided by 2 to the negative 3rd power plus 3 divided by 3 to the negative 3rd power plus negative 5 to the 0 power. What is the answer? Well, that's the end of our 8th grade lesson, and that's the end of this episode of Math Extra. But it doesn't mean the learning has to end. No. Each one of you can challenge yourself and practice what you've learned and even share it with others. So step up now so you don't have to catch up later. I'm Mr. O'Neill, and on behalf of the entire Math Extra team, be safe and be smart, and we'll see you next time on Math Extra.